And hello again. We're on page number 220. We're looking at Earth's resources. We're going to start off with minerals. There are many different kinds of objects on the Earth. One such object is called a mineral. A mineral is a non-living, naturally occurring solid that has its own regular arrangement of particles in it. So let's make it easier. Minerals are non-living and naturally occurring. An example is different types of rocks. Certain rocks can be called minerals. Other rocks are made up of a combination of minerals. By looking at how the minerals in the rock are arranged, you can often determine how the rock was formed. So minerals are non-living, naturally occurring. And let's go ahead and put down rocks for now. We don't really work on igneous rocks, so we don't have to totally memorize it. Let's take that word off. It's in your book. If you want to read about it, you can. It says rocks that form when melted rocks cool and harden are called igneous. We don't have to know igneous in 5th grade. Oh, but we do have to know sedimentary. Sedimentary rocks. Sedimentary rocks form when layers of material and rock particles settle on top of one another. Layers of materials settle on top of one another. We should be pretty good on rock layers since we ate our way through the rock layers last week. And here's an example. Here's just a big pile of different rocks that are all together. And then over time, with heat, compaction, and pressure, it can be formed into one big rock, a sedimentary type of rock. The process begins when water, ice, and wind cause existing rocks to break down to form pebbles, sand, or mud. Sometimes these small pieces mix with other materials such as plants or animal shells and bones. This loose material is called sediment. Wind, water, and gravity carry the sediment away. It settles in low areas and along the shores of rivers, lakes, and oceans. Some sediment settles in the bottoms of lakes or oceans. Over time, layers of sediment build up. The weight of new layers press down on other layers. That would be compaction. Minerals from water may act like cement, holding the particles together, cementation. Eventually, the squeezed layers become rock. Nice. So we probably need to go ahead and add in our word compaction, pressing together, and cementation, cementing or gluing, I spelled that one wrong, together. Compaction and cementation. And we had lots of examples last week of people pressing layer upon layer. Most of us use some type of icing for the cementation to hold everything back together. Too bad that week is gone now, huh? Let's see what's next. Metamorphic rocks. I know y'all sing that song with Mrs. Hughes about igneous, metamorphic, and sedimentary. Again, in 5th grade, you don't have to know metamorphic, but here's what it is. There is actually a rock cycle. And it makes sense because we saw that sediment, pieces of sand and stuff, can be turned back into sedimentary rocks. And the rock is broken down and turned back into sand. So we know there's got to be a cycle. And here is the explanation of the cycle, but you don't have to know that in 5th grade. So we're going to skip it. Fossil fuels. We do need to know fossil fuels. Oh, good. I can write down FF. I heard you say it. Con. FF con. Fossil fuels. The fossil fuels are coal, oil, and natural gas. Those are our fossil fuels. Coal, oil, and natural gas are fossil fuels. They are important energy resources. Like rocks, fossil fuels form over long periods of time. The coal, oil, and natural gas we use today formed millions of years ago from the fossil remains of organisms. This is why they are called fossil fuels. Fossil fuels formed from dead organisms or fossils. It came from fossils. And here's the fast part of it. Some plants lived, the plants died, they got buried, they got turned to peat, and over time, presto changeo, now we have coal. So here's more information if you want to know more about how specifically coal formed and specifically how oil and gas formed. It's a little different depending on what you want to make, but it's pretty much the same thing. Lots of time, heat, pressure, heat, time, pressure, and fossils. Hogs, flip, tiny, people. I guess I could put that in the right order. I'll let you do that if you need to. So let's move on to page 228, erosion and deposition. Landforms, the natural land features on Earth's surface. A landform, the shape of the land. Natural land features on Earth's surface. The movement of materials away from a place is called erosion. Movement away, or movement towards a place. Erosion, let's just do movement. Erosion is movement. It's when it's being moved. Water, wind, temperature, and other forces wear away rock and soil. Once materials break into small enough pieces, flowing water, flowing wind, and gravity can carry them away. I don't think we talked about gravity, but I like that that's in there. Gravity is one of the main forces causing erosion. In a landslide, gravity quickly pulls rocks and soil downhill. That's cool. Deposition, not the same as erosion. Deposition is the depositing, the dropping off, the building up. Man, I made 3 mistakes in a row. This is where it's growing. The main landform that we know of that gets deposited over and over and over is the delta. Deltas get deposited. Oh, this kind of looks like a delta kind of right here. All this sediment is being built up from the river as it flows up here. So it says deposition is the process of laying down materials such as rock and soil. Laying them down, dropping them off, building them up. Yeah, we can put all that in there. Water erosion and deposition. Rivers, rain, waves, glaciers. So here's what causes. They didn't say a lot about weathering, did they? I don't know if I missed it or what, but we should probably go ahead and put weathering on there. Weathering is the breaking down of rocks into sediment. So, what causes weathering, erosion, and deposition? Well, here's the answer. It's caused by WWWI, and that stands for wind, water, waves, and ice. Wind, water, waves, and ice. And then the book also said gravity. So I guess we could put that in there too. Gravity causes it also. Oh, look, there's another lovely valley right here. This valley has a small river in the bottom, but the river's not what created this valley. This is caused by a, you guessed it, glacier, especially since the word's right here. Plus, look, we're up in the mountains, and we can see some tiny little glaciers up there. So this is probably in the wintertime a giant glacier carving down the sides of the mountain right here. Sand dunes. There's some pictures of sand dunes. Sand dunes are large, loose deposits of sand. The size and shape of a sand dune depend on the speed and direction that the winds are blowing. Fields. Wind erosion can be a serious problem on farms. Bare, plowed fields can become very dry. Winds can blow the topsoil. Oh, I like that word, topsoil. It's the soil on top, yeah, that's it, the topsoil off of the fields. This topsoil is the best kind of soil for growing crops. It cannot be quickly replaced. Farmers often plant rows of tall trees along the edges of the fields to prevent or stop wind erosion of topsoil. Oh, that makes sense, doesn't it? Wait, what picture was that over there? The Canyon of Big Bend. Look at that canyon. That's over there in West Texas. The Rio Grande, that's the river down here running in the bottom of this canyon, is proof that a flowing river is a powerful force for shaping the land. The Rio Grande flows through the Big Bend National Park in West Texas. Over millions of years, the river has carved deep canyons in the mountains of the area. So a long time ago, the river would have been way up here at the top of the land, but after hundreds and hundreds and thousands of years, the river has carved its way all the way down here. weathering away the sediment, eroding it to somewhere else, and dropping it off who knows where. But that's cool that that's in West Texas. We should go see that sometime, huh? Energy resources. Oh, cool. So energy resources are broken into a few different categories. I bet we have time for these. Renewable resources. Renewable resources. I messed that one up too, didn't I? Renewable resources, they renew. That means they are made again. That's what that re means. They're made again. These things go in cycles. If you're a renewable resource, you know you are if you go in a cycle. So what goes in cycles? Well, I'm glad you asked. It's water. Animals go through cycles. Air goes through cycles. Soil goes through cycles. And plants go through cycles. I think this should be a comma right here. Water, air, animal, soil, and plants. And I abbreviate that as WASP, WASP. These are our renewables. They go in cycles. Water, air, animals, soil, like the rock cycle, and plants. Things that go in cycles because they make themselves new again. The adult animals have baby animals. The adult plants have baby plants, and they keep going in a cycle. And then water goes in a cycle, and then the air goes in a cycle because the carbon dioxide is turned into oxygen. Oxygen is turned into carbon dioxide, and then there's the soil or the rock cycle. Renewable energy resources include the wood from trees, leaves, food waste, and even manure. These resources belong to a group of fuels called biomass fuels or biofuels, which are made by living things or from recently living things. Yada, yada, yada. Renewable resources. If you're not renewable, well, that means you are non-renewable. Non-renewable resources usually come from deep underground. These don't go in a cycle, because if you go in a cycle, you'd be renewable. These take thousands of years to make. So I bet you have a good idea what these ones are. These are your FF, Con, and a couple other ones, M and M. You know what the FF Con stands for because we already wrote it down. So what does the M and M stand for? Metals and, I messed that one up too, metals and minerals. That's what the M&M stand also, because we have to dig in the ground for the coal, we dig deep in the ground for the oil, we have to mine out and dig in the ground for natural gas, we have to mine out the metals, copper, steel, aluminum, we have to mine out the minerals such as diamonds or rubies or sapphires. The earth makes all these things, but it takes thousands and thousands of years. So we can't easily have more. So they are called non-renewable because they don't renew. They don't go in a cycle. The other word we need to know is inexhaustible. Inexhaustible resources. These are resources that will never run out. They're pretty much the same thing as our alternative energies. Things we won't run out of, because we're not going to run out of solar, because that comes from the sun. We're not going to run out of hydroelectric, because that comes from flowing water, because of the water cycle, we're always going to have flowing water. Solar, hydro, we're not going to run out of biofuels, because plants are having more plants. So we should be good on crops and wood and stuff. Those are biofuels. Geothermal, we should be okay on that because that comes from the Earth's heat. As long as the Earth is hot, we'll be all right there. Solar, oh, the other one is wind. As long as there is wind blowing, we can still use windmills and wind turbines. So we've been calling them alternative all year long. They can also be called inexhaustible because they will never run out. We can't use them all up. Let's see what the next page is. 240. Biomass, wind, solar, geothermal. So if you want to read some more right there, you should know those really good. Conserving resources. There's a great topic we need to make sure we know. Conservation. To use less